Today we're talking about triangles, and we want to start with how to name a triangle. Now, what we're going to start with is a symbol for a triangle name, which is just actually a small triangle. And what you're going to then do is list the vertices of the triangle. Now, you can list them in any order you want. You can call this triangle QPT if you want. Now, notice the question is what are 4 ways to name the triangle. So just put them in any order. We can say triangle QPT. You can say triangle TPQ. You can say triangle PTQ. You could say triangle PQT. Any way that you can put these in order. So this is just 4 ways that you could do this. All right. So classifying triangles by angles. A right triangle has exactly one 90-degree angle, and I've drawn a picture of what a right triangle looks like right here. You can see the 90-degree angle that I have marked. An acute triangle has 3 acute angles. Now remember, an acute angle is less than 90 degrees. So we're going to say all angles less than 90 degrees. Okay, so all of these angles here are less than 90. They're all acute. Obtuse triangles have one obtuse angle. So an obtuse angle remember, is bigger than 90 degrees, but less than 180 degrees. Now in this particular triangle, it's this angle that I'm drawing an arrow to right here that is the obtuse angle. It's more than 90, less than 180. Okay, so let's move on to the next page. We want to classify each triangle as acute, obtuse, or right. Now the first one we look at has a right angle marked in it. So we know that this is a right triangle. The next one, we want to see if it has an obtuse angle or not. And it's an obtuse angle if it opens more than halfway. And we can see that this angle right here that I'm pointing to is obtuse. So we're going to say this is an obtuse triangle. Now the last triangle has angles that are all acute because acute angles open less than halfway, and we can see that all of these angles open less than halfway. These are acute angles. An isosceles triangle has 2 sides that are equal in length, and I've used these 2 little marks to show the sides that are equal. In an equilateral triangle, all the sides are equal in length. And you can see I have all of the sides marked the same way in this picture. In a scalene triangle, all sides are different measures, and you can see I have different marks on each side to indicate each one is a different length. Now in these pictures, we want to classify each triangle as isosceles, equilateral, or scalene. Now in this first triangle, all the sides are different lengths. So we'll say that this one is scalene. In the second triangle, we have 2 sides that are equal in length. So we know that that one must be isosceles. And in the third one, all sides are the same length. So that one must be equilateral. let's move on to the next page. In an equiangular triangle, all angles are equal to one another, and what that means in a triangle is that they're all 60 degrees. And in this picture, I've made these arcs on the angles, and these arcs indicate that all of those angles are the same. Now, the thing about equiangular triangles is that they're also equilateral. All sides are also the same in an equiangular triangle. Now, a fact about triangles is that the sum of the measures of the angles of a triangle is 180 degrees. So I'm just going to add in here of the angles. Of a triangle. We'll just slip that right in there. The sum of the measures of the angles of a triangle is 180 degrees. So in these pictures, we'd like to find the missing angle. Now we know in this first picture, since it's a triangle, all the angles add up to 180 degrees. We have one angle that measures 92 and another angle that measures 53. If we were to add those angles together, when we add them, we have 145 degrees. And if we were to subtract that from 180 degrees, we could find our missing angle. And 180 degrees minus 145 gives us 35 degrees. So our missing angle is 35 degrees. In this next picture, we're given a 50-degree angle, and by the notation in this triangle, we know that the second angle is 90 degrees. If we'd like to find the next angle, the third one, we could add 50 and 90, so we'd get 140 degrees, and we could subtract 140 from 180. And we end up with 40 degrees for our missing angle. Next, let's talk a little more about the isosceles triangles. In an isosceles triangle, the two equal sides are called legs. Where the legs meet, the angle where they meet is called the vertex angle. The third side is called the base. And the angles that are formed by the legs and the base are called base angles. Now you notice I have arcs that look pretty much the same on this triangle, and that shows that the base angles in an isosceles triangle are equal. So knowing that the base angles are always equal in an isosceles triangle, let's take a look at this picture. You're given an isosceles triangle where you're told that the vertex angle is 120 degrees. I'd like you to find the measure of the base angles. We know that all the angles in a triangle add up to 180. So if we took 180 degrees and subtracted that vertex angle of 120, we would have 60 degrees left over to split between the two base angles. Since we know the base angles are equal, we could just divide that 60 degrees by 2, right? We'd divide it right in half. And we would get that each angle is equal to 30 degrees. So that's all for today. Thank you for joining me.